This video is just for me. I am measuring the granite output voltage using the 1 kilo ohm resistor, which is this one. And then input is the metal bar. And then to the end, I'm giving the 15-volt peak-to-peak square wave. And the granite, how I optimized is it's around 39 meter. It's actually made for 1.9 megahertz. And then the final inductance is 187 microhenry. And then the capacitance, it's hard to measure because the capacitor meter doesn't give this value. So I use the generator resonance frequency, and then I think it's 32 picofarad, which makes 1.8 megahertz resonance. So LC resonance is this, and then quarter wave, standing wave is for this. So it's not very bad. So it's optimized like that. And then I'm giving the input like that because I am checking the 90-degree magnetic field, how is the 90-degree magnetic field is induced in the granite, and then making this. And then before I go into the measurement, I need to make sure that my generator has about 18 megahertz inductance in there. So sometimes I fall into LC resonance because of the generator, and then I think it's something strange result. So just to remember by myself. And then first, this is 10 kilohertz input. This is the 10 kilohertz input. Yellow probe is the monitoring the input current, and then the red probe is the output voltage in between the granite. And if I see although I give 10 kilohertz, I am having about 2.27 megahertz output. It doesn't matter which frequency I give, I have this ripple. For example, if I give like that, so something is going in and then keep coming out and then making this much of ripple. I don't know if it is because of the input or because of the granite, but it's hard to find out input. This simple structure, metal bar with 18 microhenry. Then to have the LC resonance, it has to be about some hundred picofarad. So I will show later whether this is gonna disappear or not. I can show already now. I switch off, and then I'm just adding 1 nanofarad there. 1 nanofarad parallel. So if I add 1 nanofarad, then let me see. Still it's about 2.17. So although I give input like that, but still output the resonance frequency is nearly the same. So I start thinking it's because of the granite output. So actually granite is making 2.17 ferroresonance, although I optimized for 1.8 or 1.9 megahertz. So at the moment is okay. Now I will get rid of the capacitor. Capacitor is off again. I give an input. 120 kilohertz is this, and then I'm going up, 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 up to find out the resonance. Not much dramatic. Still, yeah. This is one point that I might doubt. It's 1310 kilohertz. This could be a small resonance, ferroresonance, but the reason why I'm saying this is because it's not changing the current, input current, and then the voltage is increasing suddenly. But there is more impressive point, which is going higher to this point. It's 2.2 megahertz. And of course, input is increased. For some reason. But still, it's impossible to say this is because of the LC resonance between the generator and the metal bar. It cannot be. It cannot be 2.2 megahertz resonance there. So I think it's because of the LC resonance. It's because of the ferro resonance. And I am going up again. It's quiet, so I doubt actually and then yeah, whatever. And then there is an interesting wave coming here, which I didn't see before. It's about 900 megahertz. Let me see. Or if I insist, the low frequency, it could. I think it's because of the electric device somewhere. Whatever, and yeah, it's 900. But this is I cannot say it's a ferroresonance 900. But if I go up, yeah, it disappears only here. It's a 5620 kilohertz, and here makes some ripple, and then it's disappearing, and then going down again. The most impressive peak is here, 2.2. So then if I can make 2.2 by putting just the generator to the grenade, yes, I can make around 2.3 megahertz area. So I don't know if it is because of just grenade resonance or ferroresonance. And then there I am connecting again the capacitor, which is 1 nanofarad. And then if I see, then if I put the 1 nanofarad, then the resonance frequency must have shifted a lot if it is because of the generator. but didn't shift much, and then the resonance is still 2.3. And then I keep the uh, capacitor there, 1 nanofarad capacitor, and then I'm going down. There is always about 800 something resonance, and then I'm going down. There is a little bit of resonance, 460, and going down, going down. So I cannot find the low frequency part of this ferroresonance. So that's it again. The tested scheme is like this.